Okay, we are about to conduct our first hypothesis test. It's going to feel a little overwhelming because there's a lot of steps to this process. However, you're going to learn the flow of this pretty quickly. And luckily, the flow for chapters 8, 9, 10, and 11 are all kind of similar. And so I think once you get the hang of this, you'll be very excited to see how much easier chapters 9, 10, and 11 get. Okay, here we go. I'm on page 13 of the notes. In a study of the accuracy of fast food drive-through orders. We all know how annoying it is when they get the order wrong. Luckily, they get it right most of the time. One restaurant had 40 orders that were not accurate among 314 orders. Use a 1% significance level to test the claim that the rate of inaccurate orders is equal to 10%. Does the accuracy rate appear to be acceptable? Okay, that's all the information we get to do the entire hypothesis test. So here we go. First, let's determine our null hypothesis and our alternate hypothesis. Okay, remember that the null hypothesis is involving an equals sign. So the null hypothesis in this case, now before I do this, do you think this is going to be a proportion hypothesis test, a mean hypothesis test, or a standard deviation hypothesis test, or maybe something else? Think about it for a second, pause the video, and see if you can guess the correct statistic. Did you get it? We're not doing a mean or a sigma here, we're actually doing a proportion, because we're looking at whether or not your order was successful, and we're looking at the percent of orders that were successful. So in this case, the null hypothesis that we are going to be challenging is that P is equal to 10%. Okay, we have three choices for our alternate hypothesis, either less than, greater than, or not equal to. Remember that not equal to will be the default. So unless we see something about greater than or less than, our alternate hypothesis should be not equal to. If you read through this again, you'll notice that it doesn't say anything about being greater than or less than. We're just testing whether or not the proportion is equal to 10%. So that means that our alternate hypothesis is that we're not equal to 10%. Okay, now before we go ahead and do the hypothesis test, let's go ahead and look at what percent was actually incorrect. So I'm just going to, off to the side, this is kind of scratch work, off to the side, I'm going to do 40 divided by 314. Let's just see what happens. 40 divided by 314. And we get 0.127. So that indeed is different than 10%. The question is it different enough that we can reject the null hypothesis at a pretty high accuracy level, 0.01. That 0.01 is it's a pretty high accuracy level. So we do see that it's different than 0.10. The question is it different enough? Okay, we're now going to calculate the test statistic. The test statistic always comes from a formula. And the p-value will come from technology. And I'm going to show you how to do this. So if you flip to the second page of the my cheat sheet flowchart I made for you, you'll notice that we have a whole bunch of different branches. The tricky part of this actually is figuring out which formula to use, and so that's why I put questions on all of the branches that you can answer to help you find the correct formula. So let's read this branch right here. The first branch is how many populations do we have? I am comparing a sample to a population or testing a claim. That's what we're doing. We're testing a claim. This is I'm comparing two samples. This is I'm comparing 3 or more samples. So you can see that a lot of the tests are going to be in this first branch because we're testing a claim in a lot of these. So we're testing a claim. The next question is it a proportion? Is it a mean? Is it variance or standard deviation? Well, we know from before that we're doing a proportion. So ding, 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 we're testing a claim. It's a proportion. Here's the formula that we're going to use. In fact, I'm going to put an 8.2 right here because this is section 8.2 for doing proportions. But you should be able to answer the question. We're comparing a sample to a population or testing a claim. We're testing a claim. And it's a proportion. So here is our formula. So the formula is Z is equal to p hat minus p divided by the square root of pq over n. That's how you do it. So let's go ahead and figure out what all of these values are. P hat, p, q, oh shoot, I messed that up. P hat, p, q, n. We need to get these four values, okay? P hat is our statistic that we got from our actual data. And you can see that I went ahead and calculated it over here. And in fact, because we're using it, I'm going to grab a few more decimal places. So p hat is 0.127389. Okay, 0.127389 I'll put for p hat. P, remember, will come from our null hypothesis. So remember, way back in the beginning, we said p was equal to 0.10. So that's from our null hypothesis. Q is based off of p. Q is not based off of p hat. So in this case, Q is equal to 0.90 because it's 1 minus p. Okay, not 1 minus p hat, but 1 minus p. N is just our sample size of 314. Okay, now I'm going to do something that this problem isn't going to ask us to do, which is that I'm going to figure out our critical value. Let's find the critical value, the CV, the critical value. The critical value we always get from a table, okay? And you need to know which table to use. And which table you use is based off of what type of statistic we're doing. This will either be Z or T, or sometimes it might be F, or even something else. So because it's a Z, that means that we're going to use the Z table right here. That's going to be our table, as opposed to the T table that we saw earlier. So let's find our critical value. Notice that it's not equal to. That means we're doing a two-tail test. If it's less than or greater than, that means it's a one-tail test. Not equals is a two-tail test. So here we go. Two-tail test at a 0.01 alpha level. Two-tail test, 0.01 alpha level, means that our critical value is 2.576. Okay? So, two-tail confidence level, alpha was 0.01, 2.576. You can see that a hypothesis test can sometimes be one tail. All right, here's the idea. When we do this formula, we'll get a number. Then we'll take the absolute value of that number to make sure that it's positive. If the number from the formula is greater than the critical value, that means our test statistic is larger than the critical value and we reject the null hypothesis. If our test statistic is smaller than the critical value, then that means our number wasn't different enough to reject the null hypothesis, which means that we failed to reject the null hypothesis. So let's plug into the formula and see what happens. It's going to be p hat, which is 0.127389, minus our p, which is 0.10, divided by 0.10 times 0.90 divided by 314. Okay? That's going to be our test statistic. I just plugged in the four numbers into the formula. So here's my p hat value, subtract 0.10, and then I'm going to go ahead and press enter. Now I do that because when we divide, we need to do the order of operations and do the entire numerator divided by the denominator. If you try to put all this in your calculator at once, you might make the mistake of only 0.10 being divided by all of this stuff. So I went ahead and did the entire numerator in my calculator first before I divide. So now we're going to divide. I'm going to divide by the square root of 0.10 times 0.90 divided by 314, all being inside of the square root. Press enter. And we get a z of 1.61775. There's our test statistic. And in fact, the book If I come back to my answer guide, the book rounded it to 2 decimal places, so the test statistic was 1.62, and we do have the correct answer. So 1.62 is the test statistic. Okay, compare that to the critical value. Notice that I'm smaller than the critical value, so that means we've failed to reject the null hypothesis. Okay, how do we actually find the p-value now? To do this, we need to use technology. And so that means that I'm going to go ahead and move over to D2L because I've created a bunch of or I haven't created them, but there are a bunch of websites I found that will do this for us. And I really like them because you'll be able to use them after you leave the class. Check this out. Do you see I have in the Content tab websites for calculating test statistic or p-value? I'm going to go ahead and click that. And you see that I have a whole bunch of different websites with their section number on how to find the p-value for every test. So we're on section 8.2, calculating a p-value for a proportion hypothesis test. That's us, so I'm going to click that. Here we go. Z-test 1 population parameter. Okay, while you're doing this, make sure that you have the notes available because we'll be referring to this as we go. First, we select our, First, we select the null hypothesis. I don't even know why they give you these two. It should always be equal for the null hypothesis. And our alternate hypothesis, remember for this test, we did a not equal to, two-tailed test. Now you just plug in the numbers. Sample size was 314. The number of favorable cases was 40. The thing that we're testing is 0.10. That was our null hypothesis, 0.10. And the significance level was alpha was 0.01. So that's all I have to do. Let me know if you have questions on any of those numbers. And then we just click solve. Hopefully. It's not working. There we go. Okay, so if it doesn't work, just click it a couple times, okay? So here we go. Here's our solution. Now, before we look at the answer, here's what I want to ask you. Remember that what we're looking for is the p-value. And remember that our test statistic was smaller than the critical value. So my question is, do you think the p-value is going to be greater than or smaller than 0.01? Do you think the p-value is going to be bigger than 0.01, or do you think the p-value is going to be smaller than 0.01? And the answer is our p-value has to be bigger than 0.01. We failed to reject. Remember, we failed to reject. If the test statistic is smaller than the critical value, that means that the p-value is guaranteed to be bigger than 0.01. So let's look at the website and find the p-value. And it should be in here somewhere. Here we go. The p-value is 0.1057. The p-value is about 10%. And notice that it was guaranteed to be bigger than 0.01. The null hypothesis is not rejected. We failed to reject the null hypothesis because the p-value was bigger than 0.01. And so 0.1057 is the p-value. This was the only number I really cared about. The 0.1057 is the p-value. So the p-value is 0.1057. Now the book wanted us to round this to 3 decimal places, so the book wants 0.106. P-value larger than alpha because the test statistic was smaller than the critical value. I know I keep hammering this into you, but I promise all these tests are the same. That's why I'm repeating myself over and over. So, conclusion of the test, we failed to reject, so let's get rid of these 2 answers. We failed to reject. There is not sufficient evidence to reject the claim that the rate of inaccurate orders is equal to 10%. That is the correct assessment of this test. The other one said there is sufficient evidence to reject the claim. No, that's not the case. We did not find sufficient evidence to reject the claim. That's what failed to reject means. Finally, does the accuracy rate appear to be acceptable? So since there is not sufficient evidence to reject the claim that the rate of inaccurate orders is equal to 10%, it is plausible that the inaccuracy rate is 10%. That rate would be too high. The restaurant should work to lower the rate. That is the correct answer. Remember, we didn't prove that 10% is the answer. We just failed to reject 10%. Maybe the next time we do the experiment, we will reject 10%. The rest of these would not be the case. We did not find sufficient evidence to reject the null hypothesis. So, I know this is a lot, but every single problem follows the same flow. Null hypothesis, alternate hypothesis. Do an alpha level, find a critical value from a table. Calculate a test statistic with a formula, compare the test statistic to the critical value, use technology to find a p-value, compare the p-value to alpha, and then just answer some questions. I'm going to go a little quicker through the next example, and let's do that in the next video.